And hello, Science 20. Okay, we're going to continue looking at velocity in physics and acceleration and all that. We're going to put it all together into something that actually is kind of relatable to something that is going to affect us in the real world, and that would be this wonderful little thing that we like to call stopping distance. And so, of course, if you drive a car or something like that, stopping distance is going to be a very important thing for us to know. And so, when we talk about stopping distance, there's two things that we need to be able to uh, determine. The first one is our reaction distance. That means this is the distance that the driver travels while still reacting to the need to stop. So, you're driving down the street, you see the light suddenly turn red, you're going to have to react. Now, hopefully, that reaction time is going to be very, very small, but it is going to cover a certain amount of distance. Now, a couple things we need to understand is that there is no acceleration during this time. Okay, we do not see slowing down at this point. That's not part of your reaction distance. So it's just going to be a basic change in distance or position, if you will, equals the speed times the amount of time that it takes. The second one is going to be the braking distance, and that will be your um, that will be based on your deceleration or your negative acceleration. So you're going to have to pick one of these formulas to use. Now, usually, since we're going to be looking for the total distance, we may be thinking that that is not going to be something that we would have to worry about. Um, but we may want to use it if we need to know how long it's going to take us to slow down. So, uh, but probably what we're going to be doing is we're going to be looking at these other two uh, formulas here, but do not discount out uh, this one. Okay, this is maybe, so still need to know it. So total stopping distance is reaction distance plus braking distance. So let's work on a couple of examples of this and see how it goes. So drivers traveling 110 kilometers an hour has a reaction time of 1.50 seconds. Traffic safety engineers consider negative 5.85 meters per second squared to be a safe acceleration value on drive pavement. Based on this information, determine the minimum stopping distance required for this driver. Okay, so we know a few variables right off the bat. We know, for example, the acceleration, which is negative 5.85 meters per second squared. We know the reaction time is 1.50 seconds. I'm going to put reaction time there. We know the velocity, the initial velocity is 110 kilometers an hour. However, we got a little bit of a problem here because our acceleration is in meters per second squared and our time is in seconds. This is in kilometers per hour. We need to change this. So I'm just going to draw a little something down here and show us how we would do that. So 110 kilometers per hour. We're going to multiply that. So let's get rid of the kilometers. It's 1,000 meters per kilometer. Just put that these are 1 hour, 1 kilometer. And then number of seconds. Well, there's if you look in the data booklet, it actually tells you what the number of seconds are in an hour. But I'm going to do it this way. We're going to do it a little bit differently. 1 hour equals 60 minutes, and 1 minute equals 60 seconds. So what does that do? That means kilometers cancel out here. The hours cancel out there. The minutes cancel out like so. And so now we just multiply everything that's on the top. So that 110 becomes 110,000 meters. And then 60 times 60 is 3,600 seconds. I'm just going to want to move this out of the way a little bit for me so I can just finish up there. Now, when I do this on my calculator, 110, 3,000 divided by 3,600 is 30.5 repeating meters per second. Now, store that in your memory. You can use a rounded value when you're writing your steps down, but the reality is we want to use our unrounded value as much as possible. So if we wanted to convert that into three sig digs, it'd be 30.6 meters per second. But that is not what we necessarily want to use in our calculation. So 30.5 meters per second is what we're going to be using. Okay, so the stopping distance is going to equal. All right, well, let's go back and take a quick look at our reaction distance formula. Reaction distance from, oh yeah, it's going to be velocity times time. So coming back up here is the velocity times the time. We're going to add to that our distance traveled in acceleration. Now, let's see here. We don't know how long it's going to take us to decelerate. So we might have to do this first to get our, to figure out what the time is. And then substitute that in to our, one of these right here. Probably it really doesn't matter which one we're going to do. So let's figure out. So that's the reaction time. So this means we also have to find the time it's going to take to come to a complete stop. So in order to do that, we have to take the let me back up here so we can just make sure we're getting this right here. Okay, so probably what we're going to be looking at is we're going to do this one maybe. Now, to find the delta t, it's going to be VF minus VI over acceleration. So let's just back up to this here. Okay. VF minus VI over acceleration. Our initial velocity is going to be 0. Our initial velocity is 30.5 repeating meters per second. Divide that by the acceleration of negative 5.85 meters per second squared. So I've stored the velocity from down here. I've stored that in my calculator's memory. And so I'm going to subtract that from 0. So it's negative 30.5 divided by 5.85. That's the acceleration. And we're going to get 5.2231718 seconds. Now, when you're writing this down, if you go 5.22 seconds, you'll be fine. But this is what we should be using when we're doing our calculation. Okay, so coming back up here to the formula that we're going to be using. So again, I'm just going to jump back and take a look at what our formulas are here. And it says that we could use any of these now that we have our delta t. Any of these can be used to figure it out. So I'm going to use this one. Okay, you could use this one just as easily, but I'm going to use this one instead. Okay, so let's just jump back to where we were. So the delta, the stopping distance then, as we come to stop, is VF plus VI over 2. Just going to put brackets around this, times delta t. And I'm just going to put reaction time here and stop time here, just so that we know these are two different times that we're going to be looking at. Okay, so now let's throw all of this together. 30.5 repeating meters per second times the reaction time is 1.50 seconds. We're going to add that to final speed is 0. Initial speed is 30.5 repeating seconds. We're going to divide that by 2, and we're going to multiply it by the 5.22 seconds. But remember, we're going to use this number here in our calculation there. Okay, let me just clear that out so we have space to write. Okay, so taking the first part and times in it by 1.5 is going to give us 45. Sorry, that's wrong. I was getting one digit ahead of myself. 45.8 and then 3 repeating meters, plus I'm going to take the next part and divide that by 2, and then multiply it by the 5.2231789. Going to do that here, and I'm going to get 79.79845,943 meters. Okay, I'm going to add that to the other distance, and we end up with 125.6317928 meters. And that means we're probably going to want to round this to 3 sig digs, because that's what we've got in here for our calculations. Up here, 3, 3, 3. We're all 3 across. That means this is what we're going to round to. So it's going to take you about 126 meters to come to a complete stop. I'm going to do that again. Circle that a little different. There we go. Make it a little neater. Okay. Wow. That's a lot of work, isn't it? Absolutely. Let's try one more time. And now we're going to be looking at a similar situation, except now, instead of going 110 kilometers an hour, we're going 60 kilometers an hour. So our acceleration still going to be 5.85 negative 5 meters per second squared. Our reaction time still going to be still going to be 1.50 seconds. We're going to have to find the stopping time. So that's one thing we're going to have to calculate here, which would be our VF minus VI over A, which, but that also means we need to find our VF. and our VI is 60 kilometers an hour, and we're going to multiply that by 1,000 meters per kilometer, and then divide that by 3,600 seconds. So just give me a second here. 60,000 divided by 3,600 is 16.6 repeating meters per second. So then coming back up here, we will go quickly find our stopping time, and our stopping time is going to be 2.849, and there's more to it than that, but seconds. Okay, here we go. Stopping distance is the reaction time multiplied by the initial velocity. This time I'm going to do the other one, and I'll just kind of bring this up to remind us what that's going to be. It's VI times T plus 1/2 AV T squared. You'll see why I'd like the other version of that better. But VI times T plus 1/2 AT squared. Okay, reaction time. This is our stopping time, and that is our stopping time. Okay, this one here then will be 1.50 seconds multiplied by 16.6 repeating meters per second. We're going to add that to 16.6 meters per second times 2.849 seconds plus 1/2 times negative 5.85 meters per second squared times, ran out of room, so I'll just write it down here, 2.849 seconds squared. Okay. Just doing the first part, we get, almost exactly 25 meters, like 25.000001. I'm just going to call that 25.0 meters. Our second part is going to be, let's see here, 6, and we're going to multiply that by recall plus 0.5 times 5.85 that squared, and what we get is 23.7416, etc. I'll just leave it there for now. That's going to equal 48.7416, 169,042 meters, which is going to be 48.7 meters. Let me make that look more like an 8 here. Thank you. Okay, so that's 48.7. Now, I just want to bring your attention up here. I did all of this together into here. This is going to give you a negative number. This is going to give you a number that's larger. So that's why we have this value here. So, but anyways, 48.7 meters. Now, when we look at going at not quite double the speed, we're going to travel 126 meters versus 48 meters. That's a huge difference in stopping time. So just incidentally, that's one of the reasons why in playground zones you have um, a speed limit of 30 kilometers an hour, because if a child does run out into the road, you're going to, if you're going 30 kilometers an hour, you're going to be able to stop a lot sooner. And even if you do accidentally hit the child that just ran out right in front of you, chances are your speed will have gone down enough that the force to it will be considerably less. Anyways, work on this question on your own, as well as do these homework questions. And then we'll talk about this more in class. If you have any questions, let me know. See you in the next video.